Data is complex, and single variables that just hold one thing is not nearly good enough for what we actually have to be able to manage in the world of computer science. This is where arrays come in. This is the foundational organizational strategy in computer science for organizing lots of things in one spot. The definition of an array is a container that holds one or more pieces of data contiguously. And contiguous really just means side by side in an ordered way. Let me show you a little example with some dice. I have these dice that I'm holding between my fingers here, and each one of these is an individual piece of data. Consider these integer type pieces of data. And in this array, in this contiguous arrangement of information, I have my first entry, second, third, fourth, fifth, and sixth. Each of these could be considered individual variables from our lesson before. So this would be a single integer variable. This is an array of integers, a contiguous grouping of data. I could make this longer by adding more onto it, although in some languages, arrays are not changeable, but in other languages, and with lists later on, we're going to see that we can actually adapt things much more easily. But for now, just know enough. I can re-roll these dice, get some new values for them. So we'll see the same type of array. It's an integer array, but now the data inside of it, in the different slots, or elements as we call them, are different. The one thing that we need to remember, most importantly really in this section, is that in computer science, the first element or entry is labeled as element 0, which means the second one is the first, the third one is the second, fourth, or the fourth is the third, fifth, and sixth. Start again. 0, 1, 2, 3, 4, 5. I couldn't count. The last element is the length of it, which is 6, minus 1, because 0 is our first label and 5 is our last in this one here. And we need to know that in our programs, if I was to ask, if I had a class here, I might ask like, what's the value of the second element? And some keen student would go, I remember to count from 0, so 0, 1, 2. Element number 2 is this one, so the value is 4. Wonderful. Then I might ask, what's the value of element number 6? And some slacker would go, it's 3 because it's the sixth one. But remember, you start at 0, so 6 is actually past the endpoint. So what happens? It doesn't exist. It's a null value. In fact, your program is going to crash because you've gone out of the bounds of the array. So with arrays, we have to be aware that they contain multiple variables of information and that we need to stay within the bounds of the size of it or the length of it so that we don't try to access data that doesn't exist. In Java, our arrays all need to contain the same type of data. In Python, we could have groups of things that are, here is an array of sorts with a pen and a fork and a coffee cup. I can combine different types of things in it. An advantage of it, it's really flexible. I can have 3 things that are very different together, but the disadvantage is if they're too different and I don't remember that, when I try to access it, it's a little bit difficult to know what to do with it in a more generalized way because everything is very different inside of it. So there's some advantages and disadvantages of the flexibility that Python offers in this way. You'll see how we implement arrays in the branching videos that you take next, but just know that they're different groupings of data. You can have one thing in an array, you could have a million things in an array. The data is stored contiguously, side by side, and you need to be careful about the element numbers when you're trying to access the information so that you're confident you know what you're accessing, and most importantly, you don't go out of bounds.